Fourth grade lesson 7.10 is problem solving using multi-step fraction problems. Sometimes more than one step is necessary, when more than one calculation is necessary, and so we're going to see some exposure to that. Our essential question is, how can you use the strategy acted out to solve multi-step problems with fractions? Let's unlock the problem. A gift shop sells walnuts in 3/4 pound bags, and will buy some bags of walnuts and repackage them into 1 pound bags. What is the least number of 3/4 pound bags Anne could buy if she wants to fill each 1 pound bag without any leftovers? This really does feel overwhelming, but we take it one step at a time. They want to know how many 3/4 pound bags will she buy to fill up 1 pound bags, a certain amount, without any leftovers. So how many 3/4 pound bags of walnuts will she need to make 1 pound bags without leftovers? What information do I need? Well, that's what you would circle, right? We have 3/4 pound bags of walnuts. We're mixing them together into 1 pound bags of walnuts. How can I use that information? I can use fraction circles to model the problem. That might be the best way on this one until I understand the calculations a little more, until I get into more of the repeated addition, also multiplication of fractions. So let's have a look at the model. Describe how to act it out using fraction circles. We have 1 3/4 pound bag, so they did a whole 1 pound bag, cut it into fourths, and we have 1, 2, 3 out of those fourths, 3/4. So there's one 3/4 pound bag. Then another one, because this wasn't enough. So then we have another one, and you can see if we fit these pieces, I'm going to draw that here. If we fit these pieces from here into here, at least the one, let me draw the highlights here. 1, 2, 3 is what we had. Now we're taking one of these and putting it on there to make the full. That was not a highlighter. To make the full. And what that did was left us now with 2 of those left, right? So we have leftovers still. That was the whole thing. We want 1 pound bags, no leftovers. So we would get another, so there was 3/4 that we did, plus 3/4. And that left us with 1 full and a half of a pound. So let's get another 3/4 on there. And we're gonna take, so we have the 3/4 here, right? We're going to take one of these and color it in here, 2 of those, and color it in there to fill that up. But look, we're still left with this 1/4 that we haven't touched. So we still have leftovers, right? Let's see if that lets me erase it. Oh, good. Okay. So now what we're left with is 1/4, which is still leftovers. Well, what if we got another 3/4 pound bag? 1, 2, 3/4. That would be perfect. So we had, I better put down that we had already done this one. We did a 3/4 and it put us here with one of these. And we just need to put one more 3/4 in there. And when we put that 3/4 in there, 1, 2, 3, now we have a full pound, a full pound, a full pound, and none left over. So we needed it 4 times in order to do that. And they're showing that here. We made, had the 2 3/4 together, we had 6/4, right? And if we did that together again, 3, 6, 9/4. And this makes, that made 2, let me change this color here. That made 2 1 pound bags, but we still had 1/4 of a pound left over. So if we added the 4 3/4, then we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pounds of walnuts. And we saw that in fact gave us, 3 full pounds with none left over. That was the key word. And remember that fractions are simply a number over a number. They're a division problem. So if I have 12 over 4, 12 fours, I could do 12 divided by 4 just to see what I get. And 4 times 3 gives me 12 exactly with none left over. And that's what happened here. So this makes 3 1 pound bags with none left over. So it took us 4 of these to make it to the point where we had enough with none left over. Let's look at some more practice of this. Let's see another example and see if we can put that into play this time. At the end of dinner, a restaurant had several dishes of quiche, each with 2 6-sized pieces of quiche. Let's write 2/6 as a fraction so our brains can see it as a number, 2/6. The chef was able to combine these pieces to make 2 whole quiches with no leftovers. How many dishes did the chef combine? So he was able to make 2 whole dishes. Okay, I need to know how many dishes the chef combined. How many dishes were combined? What information do I need to use? We know that there were 2 6 pieces on all of those plates that were there, and he was able to make 2 whole quiches. So 2 6 plates left on the plates, and together made 2 whole. How will I use that information? I think I'm just going to go ahead and model that information using addition to help me through it. And I feel like for this one, it might be easier to work backwards. I know my goal is to get 2 whole quiches, these cheesy pie types of things, completely filled up with none left over. But I also know that the parts I'm working with are split into sixths. So I'm going to go ahead and just split these into sixths right now. And now that that's split up like that, I'm going to count up how many sixth pieces do I need to make the whole thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 sixths is my goal. And I'm counting 2 6 at a time because the plates that were left had 2 6 left. And I want to do 2 sixths over and over again until I reach 12 sixths. So 2 6 plus 2 6 plus 2 6, there's 6 sixths, plus 2 6 plus 2 sixths plus 2 6. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is the 12/6 goal I was after to fill in all of that. How many of those plates that had the left over the 2 6 left on the plate did I use? I used 1, 2, 3, 4, 5, 6. I did 2 6 6 times. So the chef combined 6 dishes, each with 2 6 quiche. I'll do this visually so you can see. Okay, here was the bunch of plates that they had left over like this, and all those quiches that were left over had 2 6 still there. So we took those 2 and put them here, 1, 2, and then we took a new plate that was also like this and took those 2, 1, 2. So this one was from one plate, this one was from one plate. Then we took another plate, 1, 2. This one was from a different plate. There's 3 plates so far that were taken to put that together. Then 1, 2 from a different plate, 1, 2 from a different plate, and another 1, 2 from a final plate. And that took 3 more of those separate plates to put together to build that. And 3 plus 3 separate plates gave us 6. Let's look at the share and show. Last week, Sia ran 1 1/4 mile each day for 5 days and then took 2 days off. Did she run at least 6 miles last week? That's what we're trying to find out. We know in one day she ran 1 1/4, and that she did that every day for 5 days. I'll put 5 days over here. Our goal is to find out if she ran 6 miles. Well, we would have to add this number together, 1 1/4 plus 1 1/4 plus 1 1/4 plus 1 1/4 plus 1 1/4, 5 times over to do that. Adding things, you can see where things are going in the next section. Adding things over and over will be multiply, but they're giving you a little bit of a peek at this just using the addition. We haven't learned the multiply yet, but this is a repeated addition, so you see where it's going. So I would go ahead and start just by modeling this because our brains still want to adjust to this. We have 1 1/4. I'm going to put over here. Then we have that again, 1 full with 1/4. Actually, I'm going to leave that off here because I'll just put those 1/4 together. So I had 1 whole and 1/4 on one day, 1 whole and 1/4 on a second day, 1 whole and 1/4 on a third day, 1 whole and 1/4 on a fourth day, and then we have 1 whole and we're filled there, 1/4 on the fifth day. So now I have all of my full miles, 1, 2, 3, 4, 5, 6, that got filled up, right? So when you model it, you could see what happened. So I could answer right now, did she run at least 6 miles? She did, and a little bit more, 1/4 more. So she ran 6 whole miles and 1/4 of another mile. Compare the total number of miles she ran to 6 miles. Our goal was 6 miles. She did 6 and a little bit more. So, of course, the alligator goes after the 6 and a little bit more. So, Sia did run at least 6 miles last week. We know she ran 6 and a little bit more. So, drawing the model can help you out. We could have done repeated addition just for visual sake, just for practice sake. We could do 1 and 1/4 added together, 1, 2, 3, 4, 5 times. We always start with the fractions, right? 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4, 1, 2, 3, 4, 5 fourths. And remember, when you're ending up with that improper fraction, take that 4/4 out of there, carry it over, and that's going to leave us with, it won't let me erase that, 1/4. I took the 4/4 out because that's 1 whole, carried it over, and then I have 1, 2, 3, 4, 5, 6, and that left me with 6 and 1/4, which is the answer I got here when we modeled it. The next question is the same one, but they say, what if she only ran 3/4 of a mile each day for the 5 days? Would she have made it? So we could model it, or we could add it. Do your preference. Pause this and try it. But this time she only did 3/4 of a mile each day, not 1 and 1/4. Pause, try, and then come back and see how you do. I'm going to do this both ways. I'm just going to go ahead and mark out in force the modeling version of it. I need to fill up 6 full miles. These circles are representing my miles in my brain for now. And I'm going to do 3/4 at a time, 5 times over. So I have 1, 2, 3, 4, 5, 6. That's 3 more. 1, 2, 3. 1, 2, 3. 1, 2, 3. So I have done this so far 1, 2, 3, 4, 5 times. I only had 5 days. That was 1. The blue is 2. The white is 3. The black is 4. And the red again was 5 days. 5 days. And we wanted to fill up all 6 miles. Did we? No. So did she run at least 6 miles last week if she's only doing 3/4 of a mile each day? No. She did 1, 2, 3, and 3/4 miles. If you wanted to use addition, you would have done 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 fourths. And when you divide that to find out its mixed number, 4 goes into 15. It only goes in 3 times. That's 12, with 3 out of the 4 left over. Let's look at number 3. A quarter is 1/4 of a dollar. You know that really well. 1/4 of a dollar is a quarter. A Noah has 20 quarters. how much money in dollars does he have? Well, we can model this. We can add these up until we hit 20. We could do it a lot of ways. I think I'll go with a model of it. I'm going to do dollar bills. Okay, so I've got some dollar bills out here. He's got 20 quarters, and I know that in dollar bills, it takes 4 of them, 4 quarters to make a dollar. So here I'm going to start coloring in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's my 20 quarters. And remember, my blues were representing the whole dollar bill. So I have 1, 2, 3, 4, $5. So if I modeled it, Noah has $5. And no change. There was nothing left over. We'll do one more. We have Jared painting a mug, 5/12 of it red and 4/12 of it blue. And they want to know what part of the mug is not red or blue. Oh, well, they only told me what the red or the blue was, so how am I going to find that out? Well, I have 5/12 red, 5 out of the 12. And I have 4/12 blue, 4 out of the 12. So of the reds and the blues, I have a total of 5 plus 4, which is 9/12. 9/12 are red and blue. Well, remember, this fraction means I've got it cut into 12 pieces. I have 9 of them. 9 of them are red or blue. That means the rest of it must be something else, not red or blue, right? So I'm going to take this 12 that are supposed to be there and subtract the 9 that I have that are red or blue from it, just so I can find out how many were left that weren't. 3 weren't. Modeled might be easier. I'll cut this into 12 pieces. If you chose to model it, you would need to have either the fraction circles that I have in class, the 12th pieces all put together as a whole, or just drawing it, 12 pieces a whole. Color 5, 1, 2, 3, 4, 5 of the 12ths in red. Color 4 of the 12ths in blue. And since we're not counting those, we want to know what isn't red or blue. We can look at what's left, and it is this 1, 2, 3 12ths that are not red or blue. So you could have chosen to mathematically do this, as long as you understand that that means all 12 pieces, 9 of them were red and blue, so whatever's left, 9, 10, 11, 12, 3 more gave you the answer. But if you didn't catch it mathematically, you can just go switch over to use a model and draw it out, because that helps too. So that's this lesson was just really kind of getting our brains to think about it. It's just pushing this information deeper into our brains, deeper into understanding what's going on, to help you as you go further in years.